Kirkwood Math. Hey there, we are going to go ahead and jump on into the second lesson of Module 13, 13.2, volume of cones. So get out those notes because we're going to write down the formula to find the volume of a cone, and we're going to solve some problems involving cones. All right, so our key terms here, basically the volume. Oops, this picture didn't get changed. Sorry about that. Basically, the volume of a cone. Volume of a cone here is going to be the area of its base, again, but it's going to be 1/3 of that area of the base times height. And the reason why is because actually a cone is only 1/3 of the volume of a cylinder of the same height. And I'm going to kind of show you what I mean on that next one, but for now, write down this formula that the area for a cone is 1/3 of the base times the height, or 1/3 pi r squared, because that's the area of a circle, times the height. So here's what I mean. This is our cylinder, which we talked about in the last lesson, and here is our cone. And it's kind of hard to see in a 2D picture like this, but if I were to actually take a cone that is the same height as a cylinder, had the same base as well, and I filled it up with water, I could fill up that cylinder 3 times. So a cone is 1/3 of the volume of a cylinder. So we're basically doing the same formula as a cylinder, right? The volume for a cylinder is pi r squared times height, except we have to divide all of this by 3, okay, to start, because a cone is 1/3 of the volume of a cylinder. So let's show you what that looks like, okay? So here we go. Here's our cone. We're going to use 3.14 for pi. Our formula is 1/3, whoopsie, that's a half. There we go. 1/3 pi r squared, or times height. Another way you might see this written is pi r squared times the height divided by 3, because that's basically what the 1/3 does here. This guy right here basically is just going to be 1/3 of whatever we're doing. So you could kind of do either expression, and we're basically going to do this when we're doing it on our calculator, okay? So we're going to go ahead and fill in the values we know. We know that pi is 3.14. Our radius is 2. Squared. Our height is 8. And then all of this is going to be divided by 3, okay, in the end. And then I am just going to use my calculator here. So I know that the square of 2 is 4, and I'm just going to do 3.14 times 4 times 8 divided by 3. Okay, so I'm going to show you that right here. So I'm going to do 3.14 times 4 times 8, and then all of that divided by 3. And I'm rounding to the nearest tenth. So looking at the 4 here, I'm going to go 1 to the right, and that 9 is bigger than 5, so it's going to make this 4 go up to a 5. So my answer is going to be 33.5. 33.5. My units are inches, and remember, when it's volume, it's cubed, and that is going to be the answer right there. Okay, let's try that again, but this time you can see we have a diameter, and so I'm going to have to divide that 8 by 2 to make my radius, which is 4. So my radius here is 4, and I have a height of 9 feet. So I'm going to say that my area is pi r squared times the height, area of the base, times the height divided by 3. So when I go to set this up, it's going to be 3.14 times 4 squared times 9 divided by 3. And then I'm just going to use my calculator to go ahead and do this. 4 times 4 is 16 divided by 3. So let's go ahead and use our calculator and show you what that would look like. So I've got 3.14 times 16 times 9 divided by 3, and I'm going to get 150.7 because I'm going to round down. 150.7, my units are feet, and it's volume, so it is cubed. Awesome. Okay, so now here's a word problem. We have a volcano. So for her geography project, Karen built a clay model of a volcano in the shape of a cone. Her model has a diameter. So if I'm going to draw this cone, the way that you would usually draw a cone is you kind of draw a circle at the bottom and the back of it's kind of dotted. And then you've got your center, your radius, and you've got your height here. Okay, so this is my volcano that Karen built. It has a diameter, so all the way across, its diameter is 12, and its height is 8, and we want to find the volume. Okay, so we're going to go ahead and use our formula, pi r squared h divided by 3. So I'm going to go ahead and do 3.14 times, oops, this is my diameter, so it means I need to divide it by 2 to make the radius. So I'm going to get 6. 6 squared times 8 is my height, divided by 3. 3.14 times 36 times 8 divided by 3. And I'm just going to use that calculator here. 3.14 times 36 times 8 divided by 3, and I get 301.4. 301.4 inches cubed of clay will be used in this diorama model. Okay, so here's another one. Again, there's no picture, so feel free to draw yourself a cone. Okay, it doesn't have to have the dotted line in the back. It just kind of helps you see things that are in the background. But there's my cone. This is like the one in the last lesson. I already know the volume. Oh, I keep using A for area. I'm so sorry. It's not area, it's volume. Silly me. I bet you're all yelling at me. Ms. Kirkwood, it's not area. It's volume. This is the volume. That's why we're doing cubed. Let's fix this up. So sorry. Silly me. All right. Okay. Oh, and I've ruined them here too. So go back if you did the same thing because you copied what I did. Go ahead and change this because I totally messed up on the letter here. Sorry about that. There we go. This is the volume, not the area. Okay. So erase this one as well. Volume. Okay, going back here. I know that the volume, not area, is found for me, and I'm going to work backwards to figure out the height, or sorry, the diameter, because I know the height as well. They're telling me my height is 6. I don't know what the diameter of this cone is, but I know that the volume is 32 times pi. So we're going to do the same thing we did for that cylinder. We're going to say, okay, volume is pi r squared times the height divided by 3. I know my volume, 32 times pi. I know pi is the same. I don't know my radius or diameter, but I know the height is 6, and I'm still going to divide by 3. So now what I have to do is work backwards. I want to get r all by itself. So the first thing that I have to do is get rid of this bar that's in my way, and I need to times both sides by 3. Okay, that's going to cancel this out, and I'm going to be left with pi r squared times 6. And on the left-hand side, I'm going to do 32 times 3. 3 times 3 is 9. 3 times 2 is 6. And the pi just stays there like a variable. All right, now I know I can divide by pi to get rid of that pi symbol like we did with the cylinder. Okay, 96 equals r squared times 6, and there's no dividing. Now I'm going to divide by 6 because, again, the one I want to keep, the thing I'm trying to get to is r. So I want to get rid of whatever's next to r, and whatever I do to this side, I have to do to that side. So 96 divided by 6, I'm going to use my calculator for this one. 96 divided by 6 is going to get me 16. So I'm going to have 16 equals r squared. How do I get rid of that square? I do that by doing the square root like you just learned in our Pythagorean theorem. The square root of 16 is 4, which means my radius is 4, but it wants the diameter. So what do I have to do? If my radius is 4, I'm just going to times that by 2 to equal my diameter. So my diameter is 8 inches. And I'm done. Okay. We can go back here if you want to pause and write this down. That's great. It's just kind of working backwards and using those skills from that module 7 that we were working on of isolating the variable. But when you're ready, go ahead and pause the video here, solve these 2 problems on your own, and then come back and see if you got them right. Okay, if you solve these problems, then you probably have them set up like this, and then we're going to do the calculations together. We know that this volume here is given and with the diameter is given, so we had to divide by 2 to get a 7.5 radius. So in my calculator, I'm going to go 7.5 squared times 3.14 times 16, and then divide that by 3, and I'm going to get 942 centimeters cubed. Then on the other side, my radius was given, so I didn't have to do anything. I just plugged it into my equation. So I'm going to have 2 squared times 3.14 times 3 equals divided by 3, and you're going to get 12.6 if I'm rounding to the nearest tenth. 12.6 feet cubed. Now notice that in order to show my work, I am at least showing this part of my formula. I'm showing that I know what I'm doing and I can plug in the correct numbers. This is super handy to prove to me you know what you're doing and to give me that extra help on your tests so that I can see, did you make a tiny mistake and you get half credit, or do you really not know what's going on and you need to get some help on that. So you got to show that work. Even though you're using a calculator, you got to write out that formula, show me what you're working with there, and then you can solve them and give me your answers this way. And like before, our units are super important. Make sure you put your units and make sure they're cubed because we're working with volume. Okay? If you have any questions, come and let me know, and I will see you next time to find volume of spheres.